My name is Ariella Musai, and I will be presenting on behalf of Group 11 on our design of a tri-band antenna for use in mobile devices for the TV, Wi-Fi, and CBRS bands. Through technological advancements, multiple communication systems are integrated into mobile devices. Since each communication protocol may operate in a distinctive frequency band, instead of using several antennas, it is highly desirable to have a broadband or multiband antenna to meet the antenna needs of multiple systems. The Wi-Fi band operates at 2.5 and or 5 GHz. The CBRS band operates between 3,550 MHz to 3,700 MHz, and the TV band operates between 54 to 88 MHz for the more prominent channels of channels 2 to 6. A multiband antenna is an antenna which operates in more than one frequency bands. Dual band antennas operate at 2 bands, and a tri-band antenna operates at 3 different bands. A microstrip patch antenna with a U-shaped slot was used in our design of a tri-band antenna. A microstrip patch antenna consists of a radiating patch on one side of a dielectric substrate which has a ground plane on the other side. The diagram on the right illustrates the basic form of an L-fed U-slot antenna. For our design, a U-slot antenna COMSOL model was obtained from an online resource, and this was used as the design's base. By comparing the designs of other U-slot antennae operating in the design's required frequencies, parameters of the existing model were subjectively altered, and the S11 plot was analyzed to determine if the antenna was operating at the desired frequencies. The material type was changed from air with a permittivity of 1 to FR4 of a higher permittivity of 4.5, and the parameters were changed to the values tabulated on the left. The design antenna is illustrated on the right. Unfortunately, even by exhausting all possible values for the different parameters in the existing model, the TV band could not be obtained as shown in the S11 parameters above. The design antenna at the Wi-Fi band of 2.4 GHz with a gain of -11 dB, and at the CBRS bands of 3.5 GHz with a gain of -4.5 dB. Its Vosswurr graph below illustrates a power reflection of approximately 2 to 1 between 2.7 GHz and 3.3 GHz. Since the Vosswurr is 0 at the desired frequencies, more detail into impedance matching has to be done to get the Vosswurr above or equal to 1. The antenna's electric plot is shown on the left, with there being the highest electric field density within the antenna. The radiation pattern shown on the right is omnidirectional with a donut shape with a maximum and minimum gains of 0.02 decibel and 5.6 by 10 to the -3 decibels respectively. The diagram on the left illustrates the 2D far plot at 2.4 GHz where the radiation is bidirectional at 0 degrees and 180 degrees with nulls or areas of poor radiation or reception at 90 degrees and 270 degrees. The radiation pattern at 3.5 GHz, as shown on the right, has a tridirectional radiation at 0 degrees, 90 degrees, and 180 degrees with zero directionality at 270 degrees. In conclusion, 2 out of 3 desired frequency bands were acquired, with the Wi-Fi band having a gain of -11 decibels and the CBRS band having a gain of -4.5 decibels. The Vosswurrs of the desired frequencies were below 1, and the antenna had a donut-shaped radiation pattern which is excellent for the band's applications. Thank you for watching.